You spell his name starting with a T, but you don't pronounce it. So just say Ptolemy. He lived around 100 AD, so he's now after Christ. He wrote a book in Latin that later was translated by Arabic astronomers. The book was lost. Remember earlier I told you the Arabs had a sense of a renaissance in the Middle Ages, and then they gave the stars their common names that we use this day. They found a lot of the books that were lost in Latin, and then they translated it to Arabic. they found Greek books, they translated it to Arabic. Then in the Renaissance, in 1400, 1500, we took those books in Arabic, we translated it back into Latin and back to Italian and all of that stuff. So if it wasn't for the Arabs, a lot of those books would have been lost. The old books by Aristotle and Ptolemy and all of those, some of the poetry of the Greeks and stuff like that. So it's interesting how civilizations transmit knowledge from one to the other throughout the history of the civilization. Okay, so his book was the standard book on astronomy. This thick. If you were a student now, back then in 400 AD, 500 AD, 600 AD, if I was an astronomy teacher, I would probably say, okay guys, here's the syllabus. We're going to use Ptolemy's book. Of course, there's no other main book. Go to the bookstore and get it. I don't know if they have bookstore, but probably had it. So his would be the main book to use. Big, thick book. His book defended the geocentric model. See, so it wasn't correct. So he defended that the Earth is the center of the solar system. The Earth is the center of the universe. And it became the classic textbook of astronomy until the Renaissance. Okay, here are the features of his model. Okay, so according to him, all the planets, including the sun, revolve around the Earth. Not only the planets, but also the sun. So let's put a picture up here. Okay, so you see on the top it says here, Ptolemaic Model of the Universe. So in his book, he probably had a picture looking like this. And then we got the Earth at the center. The Earth doesn't move at all. So he says, you see, the Earth doesn't move, therefore that's why stars don't parallax. He's wrong, of course. And then beginning with the moon, everything goes around the sun. So moon goes around the sun, Mercury goes around, they go around the Earth. The moon goes around the Earth, Mercury goes around the Earth, Venus, Sun, Mars, Jupiter, Saturn, and stars are fixed on the, what is it? Celestial sphere. They actually thought there was a sphere like that because they had no way of finding the distance to stars, right? So they thought all the stars were equidistant from them. Okay, they're all equidistant on a sphere. And then if you ask them, well, what's beyond the sphere? Don't know, the heavens, God. Okay. Notice, by the way, something interesting here. He knew about all of the planets up to Saturn. That means these planets are all planets that can be seen with the naked eye. So if somebody asks you who discovered Saturn, who discovered Jupiter, tell them there is no discovery date for those. We always saw these planets. So no one should tell you that Saturn was discovered. It has a discovery date. Jupiter. These are all the naked eye planets. Saturn, Jupiter, Mars, Sun, Venus, Mercury. Notice, however, he didn't know about any of the moons of the planets. He couldn't see it. Those all have discovery dates. Okay? Okay, what else? The stars are stuck on the crystalline sphere surrounding the Earth. Okay, next. The planets make two paths. The larger one is called the Deperate. So if you notice here, interesting thing, see you have Mercury. Mercury is going around a small circle like that. But it's not just standing there. See, here's the Earth. Mercury is not just going around a small circle, it's also going around the Earth. So the combined orbit of Mercury looks like this. Like that. Something like that. Same with Venus. It goes like that. Does the sun do that? According to Ptolemy? No. The sun just goes straight. Okay? Does Venus do it? Yeah. Does Jupiter, does Saturn? Yeah. They also have the little circle. So this big circle is called the Deperate. The small circle is called the epicycle. Okay? So he drew a picture like this to illustrate for us what he means. See here? He says here is the Earth. Here is the center of the Deperate. So the planets go like that. Like that. Okay? So then he draws the path of the... See, if you draw all those little circles, and then you say, where's the planet? The planet is going like this, coming back. This is what I drew a minute ago. Like that. Okay, here's another picture similar to that. We get this actually from his book. It looks very similar to some of the drawings of Michelangelo. You know, when he conceived of things, he actually conceived of flying objects. You know, Michelangelo. So here's Ptolemy's way of explaining to us this mechanism. He says, imagine that the Earth is at the center of a wheel, and then there's another wheel stuck on this wheel, and the planet is stuck on that wheel. And then this wheel is turning, and then it's stuck on this wheel. Therefore, what would be the motion of the planet? You see? And then it would be whatever we just illustrated. So you see, if this guy is turning this way, so it would come like that. So that's how he envisions it. And then he draws something like this. You see? Okay, so why does he do this? Why does he have an epicycle and a deperate? Why does he do that? He's trying to explain one of the hardest questions that astronomers of his day were trying to explain. And the question was, why do the planets retrograde? Okay? That's what he was trying to explain. So his answer is, the planet retrogrades because it's moving forward, but because it's going in a small circle, once in a while it's going to move forward, then it's got to move backward. You see? See the backward motion? That's retrograde right there. Backward, then it starts moving forward again. So this part of it is the retrograde part. Retrograde. Then it moves forward. This is called prograde. Prograde. Prograde means it's going the way it's supposed to go. And then over here, retrograde, prograde, retrograde, prograde. You see that? So Ptolemy sees the retrograde happening in the sky. And he says, I got to explain this somehow. Okay? And then he comes up with this mechanism. Okay, so if we go back to his picture, we notice something else interesting in his picture. Besides the little circles, we notice that, you see he's got the Earth here. He's got the sun here. And then he's got this imaginary line. You see, there's an imaginary line between the Earth and the sun, centers of the epicycle of Mercury and Venus. and the sun. This ensures that they are never far from the sun. Very clever guy. So he says, when Venus is doing its little epicycle, the sun has to be in the background. Same thing with Mercury. Okay? That means Mercury is going to be doing this, right? It's going to go like that. Venus is going to go like that. But the sun is also going to move with it. So by the time that the sun gets here, Venus is going to be doing its thing, you know. Venus is probably going to be somewhere here. And then Mercury is also going to be somewhere there. So if Mercury was here to begin with, and by the time it goes around, maybe it's going to be somewhere here. So I should also be able to draw a straight line between the Earth and the center of this line and the center of this line. You see that? How about Mars though? Does that restriction not hold for Mars, Jupiter, Saturn? The answer is no. When the sun is here, Ptolemy would say Mars can be anywhere. It could be down here doing its thing. Jupiter can be down here. Jupiter can actually even be on the other side doing its thing. So he would say these three, they could be doing their own thing independent of the sun. But Mercury and Venus gotta be in between the sun and the earth. Okay, why is that, Ptolemy? What are you trying to explain by doing that? Okay, what is he trying to explain? Well, notice, if this is true, when you view the Mercury, when you view the sun, they're always close to each other, right? When you view Venus and the sun, that means Venus and the sun and Mercury and the sun, they're always kind of close to each other in the sky. Whereas Mars, it could be anywhere. Okay? So what phenomenon was he trying to explain by doing this? Let's go to the next page. He was explaining the problem known as the maximum elongation of Mercury and Venus. So back then, the astronomers knew about this problem. And they didn't know how to answer it. So he says, aha, I got your answer for you. There's an imaginary line between Earth and the sun. Venus and Mercury got to be close to that line. So this explains why the planets Mercury and Venus are never seen at a person's zenith at night. This is called the problem of the maximum elongation of Mercury and Venus. And he says, I've got the answer for you. Again, his answer is wrong. It's clever, but wrong. Remember in the previous lecture we said something known as a zenith. The planets are always inside of the zodiac. The planets are always in the zodiac. So if I'm looking in the sky, right, there's a strip like this. The sun is rising, setting, rising, setting. The planets are always in that strip. They're never going to be way too south. They're never going to be way too north. Okay, all the planets are in that zodiac. The difference with Mercury and Venus is that when the sun sets at night, they're still in that strip, but they're only in the western sky. Okay, so let's say tonight the sun sets at 6 p.m., right? 6 p.m. When you go out to look for Mercury and Venus, go up about 20 degrees, 27 degrees for Mercury, no more than that. If you see a planet there in the western sky, that's Mercury. If you don't see it, that means it's below your horizon. Give up hope of seeing Mercury. Don't even look over here on the sky. Okay? How about Venus? Venus, you can go up more, about 40 degrees, 45 degrees, 47 degrees. And Venus will be the brightest looking thing in the sky. It's where women are from, right? It's got to be bright. Okay? It's got to go 47 degrees. You see a bright object that doesn't twinkle, That's Venus. If it's not there at all, that means it's below your horizon. So never look for them at your zenith. Never look for them on the eastern sky. Okay? However, in the morning, let's say it was below your horizon, right? At night. And you really, really want to see Venus. It's below your horizon. So wake up a little early in the morning. What's going to happen? Now, before the sun rises, Venus is going to rise. Before it. You see? That's why you couldn't see that night. It was ahead of the sun. So you wake up in the morning, you look in the eastern sky, there's a really bright object before the sun is rising. That's Venus. That's why the Babylonians called Venus the evening star and the morning star. That's the famous name for Venus. Evening star, morning star. The Babylonians thought it's two different stars. But we now know it's a single planet. Sometimes it's a little behind the sun, sometimes a little ahead of the sun. You see. Venus is a little harder to see. It's not as bright looking. You see. So the question why? I mean, the astronomers looked and looked and looked. They said, why is Venus and Mercury always there? We can never see them here. Ptolemy said, this is my answer, the imaginary line. But if you really think about it, it's kind of like a made-up answer. Okay, where did this imaginary line come from? Who made it? He would have said God made it or something, you know. So now we're going to actually see the correct answer. The correct answer is given to us by the Copernican model. Okay. Okay, so Mercury is always within 28 degrees of the sun. Remember what I was saying? You can see Mercury above the sun, 28 degrees. If you don't see it there, then it's ahead of the sun. Venus is 47 degrees. You can see in the western sky. Okay? Now we go to Renaissance astronomy.